Hello all, welcome back to yet another problem. Today let us solve the lead codes daily challenge. The problem is possible bipartition. So we want to split a group of n people labeled from 1 to n into two groups of size, two groups of any size. Each person may dislike some other people and they should not go into the same group. If they are in dislikes vector, we should not they are two people should not go into the same group. Given the integer n and the array dislikes, where dislikes of I equals to ai and bi, that indicates that the person labeled ai does not like the person labeled bi. Return true if it is possible to split everyone into two groups in this way. So we want to say whether we can partition into two groups such a way that if two people are disliking between each other, then they stays in two different groups. So let us take the example 1. In example 1, the n is equals to 4, and as you can see, we can have two groups. Let us say I am having a group A and B, and now let us see the dislike vector. Here 1 and 2 are disliking between each other, so let us put 1 in group A and 2 in group B. And as you can see, 1 and 3 is disliking between each other. 1 is already present in group A, so we can put 3 in group B. And in the third one, 2 and 4 is disliking between each other. 2 is already in group B, so we can put 4 in group A, and so on. So such that we are able to categorize into group A and group B, and all the disliking peoples are staying in two different groups, and it is possible to bipartition these peoples into two different groups, so we can return true. So example 2 returns true. So let us see the example 2. Sorry, example 1 returns true. So the example 2 is n equals to 3, and the dislikes are and we can have a group A and B as well, and 1 and 2 is disliking between each other, so one we can put 1 in group 1 and 2 in group B, and 1 and 3 are disliking between each other, so 1 is already in group A, so let us put 3 in group B. And 2 and 3 are disliking between each other, but 2 and 3 are belonging to the same group. We cannot say, put in same group if since they are disliking between each other, so we can just return false. So hope you understand the problem. We want to bipartition the peoples in such a way that the disliking people stays in two different groups. So how can we solve this problem is basically let us try to visualize this disliking by connecting them as a graph. As you can see, this is the example 1 and this is the example 2 and this is the example 3. So we want to bipartition into two groups. Let us say we are going to bipartition the two groups in A and B, group A and group B. So this is the three examples. I have just connected them with their edges as that denotes the dislike between them. So one and if there is an edge between 1 and 2, then it denotes that one dislikes 2. And if, since in this third example there is an edge between 2 and 3, that means 2 and 3 are disliking between each other. So in such a way that I have just drawn the graph, let us analyze this problem a little bit. So if one is in group A, then two should definitely be in group B. And since 2 is in group B, definitely the 4 should be in group A, because we are having only two groups. I hope I'm making it clear. And as you can see, 3 is connected with 1 and 1 is in group A, so this 3 should be in group B. So we have done with this we have done with this example. So let us go and do the same thing in group in example 2. So let us say 1 and 2 are connected with each other, so we can put 1 in group A and 2 in group B. And as you can see, 2 and 3 are connected between each other, and 2's 2's group is B, and let us put 3's group as A. And there is an edge between 3 and 1, but you can see that 3 and 1 are having the same group ID. If I call this as a group ID, as you can see 3 and 1 is having same group ID, and definitely I cannot have like this. So let us analyze the same, let us do the same stuff over example 3. 1 and 2 are disliking between each other, so we can put group A for 1, and we can put 2 in group B. And wait a minute, there is an edge between 1 to 2, 2 to 3, 3 to 4, 4 to 5, and also there is an edge between 1 to 5. I have missed it. Now I will just put an edge between 1 to 5. There is an edge between 1 to 5 as well. So now we can fill the groups. So as 2 and 3 there is an edge, 2 is in group B, so we can put 3 in group A. And if 3 and 4 is in group 3 is in group A, so 4 should be in group B. And if 4 is in group B, and 5 should be in group A. And if 5 is in group A but 1 is in group B, as you can see both are having the same group, both are in same group. So what does that mean is we are not able to bipartition if the adjacent is having a same group ID. So this is the exact property of bipartite graph. Bipartite graph is nothing but if we can say a graph where if we take every adjacent nodes, if we are able to color every adjacent nodes with two different colors, and the adjacent is not having the same color, then we can say that graph as a bipartite graph. So our ultimate goal now, our ultimate problem boils down into to find the graph is bipartite or not. If we know that the graph is bipartite or not, we can just say that if the graph is bipartite, we are able to partition into two groups in such a way that the disliking people will be in two different groups. If we are not able to do a bipartite, if we are not able to say it is a bipartite graph, then we can just return false, and that is the problem states, right? So our ultimate problem is to find whether the given graph is a bipartite or not. So how can we do this problem? So we can solve this problem using BFS or DFS. What we can do is we can assign a color in the sense we can assign an ID to assign an ID to a node, and we can go for its adjacent, and we can color the opposite if we can color an opposite color in the sense we can give the opposite group ID to the adjacent nodes. And if we found any node which is already being visited, and if it is also having the same group ID, then we can say that is not a bipartite graph. I hope I'm making sense. What I mean is I'm standing at this particular node 1, and I am saying that it is not yet visited, so I give the group ID to B A. Then I will go to its adjacents, and I'm seeing that its adjacent is not having the same group ID A. So what I will do is I will give the opposite group ID of A, which is B. So and I will visit 2 as well. So now I will go for adjacent nodes of 2, and I will be giving the opposite group IDs of 2, which is A. So 4 is also given the group ID A. 4 is given the group ID A. And I will be coming back, and I will be going for the one adjacent, which is 3, and the opposite group ID, which is nothing but B, I can give because 3 is not yet visited, and I will visit 3, and I will give the group ID 3. And you can see that I'm able to visit all the nodes and I'm able to give the group IDs in such a way that the adjacent nodes is not having the same group ID. So this is a bipartite graph and we can say this is true. But let us come for the example 2. I will be starting with the node 1 and 1 is not yet visited. So I will visit that node and I will give the group ID to be A. And then I will be going to its adjacent, and as you can see this adjacent node is not yet visited, and I will give the group ID and I will give the group ID opposite of A, which is B, and I will go to its adjacent of 2, and I'm saying 3 is not yet visited, so I will visit 3 and I will give the opposite group ID, which is A, and I will come back and when I backtrack I will be seeing that one adjacent is 3 is also an adjacent for 1. So when I go for 3, it is already being visited and it is having the group ID which is same as this one. So this group ID is becoming equal, so we can just say we can return false because we cannot have two adjacent nodes having same group ID. So this is a DFS solution. We can do that. We can do this in BFS as well. I will teach you in both the solutions. First, let us solve this problem using DFS. So what we can do is, so let us have a visited vector int visited of size n plus 1. It is a one based indexing and we can say it as 0. Now we can first form a graph vector of int graph of size n plus 1. So we are having a graph. Now we can create a graph. How we can create a graph? We can iterate over this dislikes, dislike of my dislikes, where A is the dislike of 0 and B is nothing but dislike of 1, and I can say it is a bidirectional graph, bidirectional edge. So graph of A dot pushback of B. So by this way we can just create the graph. Once we created this graph, we can check whether this graph is a bipartite or not. So how can we check whether this graph is a bipartite or not? Let us consider this is going to be a disconnected graph. Disconnected graph in the sense we are having multiple components. Considering we are having a multiple components, what we can do is we can run a for loop int I equals to 1, I less than or equals to n, I plus plus. If this is not yet visited, if visited of I is not yet visited, if this is not yet visited, what we can do is we want to visit this node and color the node with color the node in the sense we want to give the group IDs. So we can also have let us say we can have a map called group IDs, map int of chars. Let's have an unordered map int char mp. I'm going to color the opposite color. I'm going to give the group IDs. I'm going to have the map. I'm going to have the IDs in my group, in my map. Now what we will be doing is, if it is not yet visited, then I can visit this particular node with the group A, and then I can go and search for its adjacent nodes and I can give the opposite group IDs. So I will do a DFS. DFS in the sense I will be checking if is bipartite. If this function is going to return me a false, I will be returning false, else I will be returning true at the end of the day. If I'm able to give all the nodes by having different group IDs, then I will return true. If this function is returning me a false, is equals to false, I will just return false. So this bipartite function takes a parameters graph, then a n, then I will also pass visited, I will also pass MP, and the current group ID is A. Current group ID that I can give for this current node is A, and the node is nothing but the I. I is the current node. So we can have a private function. So let us say bool is bipartite, which takes the arguments vector of int graph, then int n, vector of int visited, then an ordered map of int char mp, and this is going to be the group ID int. Instead of that, we can have it as char group ID, and this is going to be the int node, which is nothing but u. Super. So this is going to be our bipartite function. We are checking whether this is visited or not. If visited of u, if this is already being visited, then we can just return true. We don't want to say anything else, so we can just return true. If it is not yet visited, we want to visit them, so we will be visiting this visited of u is equals to 1. So after visiting them, we can give the group ID for this current node, which is the MP of u is equal to group ID. So we have given the group ID as well. After giving the group ID, now we want to go for its adjacent. So I will go for its adjacent. For auto adjacent nodes in my graph of u, what I will be checking is if this is not yet visited of, I think we can eliminate this line because we will be checking inside here itself. If this is not yet visited, then I will pass this is bipartite function again. Is bipartite function again. I will pass the graph n, then a visited, then a map, but I will pass the opposite group ID. Opposite group ID in the sense, if group ID is, let us say int, the opposite group ID, is equals to, if my group ID is A, then I will give B, else I will give A. So the opposite group ID I should give to this adjacent node is this variable opposite group ID is passed, then the current node adj. I want, and this function is going to return me true or false. If this function is returning me a false, I will just return false. Else, not an issue. Else, if it is already being visited, we want to check whether this is having the same group ID or not. If my MP of adjacent group ID is equals to MP of u, which is the current group ID, we can say it as group ID itself. If this is equal, if both are equal, then we can return false. If either the case is not happening, we can just return true at the end of the day. So that is it. I hope this should work. What I'm doing here is I'm first creating this graph. After creating this graph, I'm having a for loop since I'm considering it as different multiple components, and I'm having a for loop. And if it is not visited, I'm going to call this is bipartite function, and I'm passing the current group ID as A, and I'm saying visit this. After visiting, I will mark this current group. Mark this node with the current group ID, and I will take the opposite group ID. This opposite group ID is useful to mark the adjacent nodes. So if it is not visited yet, then I will call the isByParted function again, and I will pass the opposite group ID and the adjacent node. If this function is returning me a false, then I can just return a false. Else I can return else if this is already being visited, then we can just return false as well. So at the end of the day, if I'm not facing any issues, I will be returning true. So let us try to run our code and see whether it gets accepted, after which we can confirm it. Okay, okay, MP, why is it so? Group ID, oh sorry, it is ID. Superb, it gets passed. It gets accepted for all the 3 test cases. Let us submit the code. It should work. Great, it gets accepted. Superb. This is a DFS solution, and let us do time complexity analysis. The time complexity for this solution will be this. Let us consider this is going to be an order of n, and this is going to be an order of m, and this is going to be an order of n, and this Bartlett function is doing normal BFS. And if there are e edges and there are n nodes, then the total time complexity will be n plus e, and the space complexity here will be an order of n, but n plus e as well, because we are actually having a graph here. We can reduce this two vector into a single visited vector, and we can have an integer variable denoting 0 or 1 as group A or group B respectively, and we can eliminate this unordered map as well. But for simplicity and for more understanding thing, I have mentioned as a map here, so that it will be easy to understand why this is a group ID and what is the opposite group ID and so on. So hope you understand this problem using DFS solution. Let us solve the same problem using BFS. Solving the same problem with various solutions is really a nice thing, so that we can actually have a clear understanding of all the algorithms and stuffs. So let us solve it using BFS now. How are we going to solve this problem using BFS? Let us take the same example. And as you can see, we are in BFS, we will be using a queue data structure. So let us have this, let us consider this as a queue. And wait a minute. Okay. First, what I will be doing is I will be visiting this one. It is not yet visited, so I will do a BFS on that. So I will put I will visit one, and I will mark group ID A for one, and I will go for its adjacent nodes, and adjacent nodes in the sense I will go for its next level. So I will be deleting this, and I will be pushing all the adjacent nodes into my queue now. So I will be pushing 2 and 3 as well, and these are not visited yet. So I will visit 2 and 3, and I will mark its group ID to be opposite group ID, which is B. Superb. Now we have processed this. Now we will be processing the next level, which is 2 and 3. We will be processing 2 and 3. We will pop this 2, and I will be pushing the adjacent nodes, as one is already being visited, and I will check whether the group ID is same or not. It is not same, it is opposite, so we don't want to care about that. So now 4 is not yet visited, so I will visit 4, and what I will do is I will mark the group ID to be opposite group ID, which is A. Now I will process 3. I will pop this 3 and I will see the adjacent. Adjacent is 1. 1 is already being visited and it is having a opposite group ID. So we don't want to care about that. And similarly 4 is also processed, and when queue is empty we can just return true. So this one we can do for example 1. Now what we can do for example 2. So let us do the same BFS for this example 2, where I will be inserting 1, it is not yet visited, and I will put the group ID as A, and while I'm traversing its adjacent I will push 2 and 3 since it is not yet visited, and I will put its group ID to be uh, B since it is opposite. And when I process 2, now I have already processed 1. Process 2, I will check its adjacent is 3 and it is already being visited, and it is containing the same group ID, so we can just return false. So by this way we can do a PFS traversal here. So I will actually retrieve the same retrieve the same code, and I will just modify this is bipartite function into a BFS code. What I will do is let us keep this create graph and map and visited vector as it is, and we can also have this for loop, and we can do the same thing in this if condition as well. But inside this bipartite function we are going to do a BFS instead of DFS. So what we can do is we can create a queue of integer, where let us put q here, and we want to insert the current node into my queue, and we have visited it, and we have marked the group ID as well, and we have taken the opposite group ID for now. So now what we will be doing is this I think this opposite group ID can be taken into our while loop. So now our standard BFS algorithm looks like, if my queue is not empty, then I will first pop out auto current node is equal to q dot print, and q is popped out. Now what I will be doing is I will go for its adjacents. For auto adjacent in my graph of cur, if this is already visited, if sorry first if it is not visited of is not visited, then let us visit them. We have marked it visitor, and we will also mark its color, mark its group ID to be the opposite group ID. So MP of edge is nothing but MP of edge is the opposite group ID. Right? But if it is already visited, else it is already visited. If it is already visited, we want to check the group ID. If my MP of pair is equal to MP of adjacent, then I will just return false. So this is the case we can add here, and at the end of the day we are going to return true if q is empty. Now let us run our code and see whether it gets accepted. It gets a wrong answer. Let us see what happens. Yeah, the failure is because this is not the generalized group ID. You want to put the group ID for MP of current. If my MP of current is the current group ID, it is not that variable. Now let us run the code. Okay, there is some other error, I guess. Sorry, we have visited, but we have not pushed this current adjacent node into our queue. That is the wrong answer we are getting. So now let us submit the code. Yeah, it gets accepted. Let us submit the code as well. Yeah, it gets accepted. So this is the approach by BFS, and the previous solution is through DFS. And hope you like this solutions and approaches. Let us see in tomorrow's Street Code Daily channel, and then bye.